Right, very quick reminder as usual. For your makeup lecture, I have already released it. It's on the finishing off the doubly linked list and also a little bit about Java interfaces. These will be required material for you. And just make sure you complete them by March 20th, which will be your written test number 2. You do have enough time to finish them. And for your assignment number 2 solution, my apology, I made a typo. Okay, I want to show to you. So if you look at the assignment number 2 solution documents over there, so I did include a link for your source code, right? You can definitely take a look and play with it. However, when I said there will be some walkthrough video and notes of the solution, unfortunately that was a typo, right? I didn't really have that information, resources. But if you really want me to go over the source code with you, more than happy to do so. Just drop by office hour. We'll make an appointment. Just reach out, all right? That's something I would like to clarify, just in case you're still waiting for the video. I don't have one, unfortunately. Okay. And then for Monday's lecture recording, in case you're still waiting, I'll make it available early this afternoon. I'll make sure it's there for you if you want to study for that. Okay. And let's do a very quick recap about what we said last time. So we introduced the idea about a LIFO stack. So whenever you think about the LIFO, the stack data structure, always think about LIFO, last in, first out. We're going to see another criterion for storing the, for retrieving the element is called FIFO, first in, first out. That's something we'll see a little bit later today. And we talk about how you can push and pop elements from the stack, right? That's something very important for you to know. And also we talk about how you can declare an interface of a stack. Right? Especially we're using generic parameter. We briefly talk about it. You want to make sure you also review the required material for your assignment number 2, which I keep mentioning. You will need that throughout the course. And we talk about how you can try to push different elements, different types of element into the stack, and accordingly pop off different types of element from the stack by declaring different types over here. Also make sure you know how to manipulate the stack in this way. And later on, when we talk about other interfaces, for example, queue, it can be manipulated in the same way, right? Just make sure you can do that. And we talk about the different operations, like a size, top, push, and pop for the stack operations, and how we can implement it using a primitive array. And we talk about its running time as well. If you're treating the end of the array as the top elements of the stack, you actually got a very win-win situation. You got constant time. Asymptotically for every operation. That's pretty good. But for this course, you ought to know other alternatives. Are they good or bad? The 2 alternatives that we spoke about was about how to implement using singly linked list. And we spoke about scenario 2 and scenario 1. Scenario 1, you're treating the first elements of the list as the top of the stack. For scenario or strategy number 2, we're treating the end of the list as the top of the stack. You ought to know how to derive the asymptotic upper bound accordingly too, which we also discuss. And the exercise you should really try would be, what if we try doubly linked list as the implementation? And then you want to divide into 2 cases. Case number 1, the first of the list will be top of the stack. And the other one, the last element, will be the top of the stack. Right? Try these exercises. I think that will reinforce your understanding, which is important. Do you guys have any questions until now? Okay, today's plan. I would like to review a little bit about what you should know about polymorphism, dynamic binding, using the example you will see on the slides. And then I want to show you some really cool thing about defining generic collection, your own. I'm gonna show you some example on the paper, and I encourage you to really put them onto Eclipse as well. You'll be very nice to broaden your knowledge about programming. I'll do that first, and then we're gonna dive into hopefully 2 to 3 examples about illustrating how useful a stack can be. And then take a break, and then we do Q. Q should be rather straightforward. I do have one exercise to do with you. If I cannot finish that today, I'll do that next Wednesday. Don't forget, next Monday is your programming test 1, right? So we don't have any lecture. Well, I'll meet you in the Williams Small Center, like the same venue as you took the written test. All right, let's now dive into a little bit about polymorphism, dynamic binding. And this is something you would have learned already in 2030. That might be a long time ago. So let me give you some reminder. If you really find that you need some very detailed review on the polymorphism and dynamic binding, that will be up to you. All right. But let me just give you a very quick recap. So we talk about, first of all, let's talk about static type versus dynamic type in Java. All right, let's talk about this. And I would say, let's now, since you guys learned about inheritance back in 2030, let's bring inheritance into play. Okay? So let's say I have some inheritance hierarchy. Let's say I have a superclass called A. Just make it easier, for us to, make it easier for us to talk about. Let's say we got two subclasses. Let's say we got class B here, and also we got class C over here. And let's have one more. Let's say we got class D. It's a very simple hierarchy, and for each arrow over here, that means B extends A, C extends A, and D extends C, right? That's something you know from 2030. What is static type? By definition, static type will be the type you declare the variable to be. Declare type. For example, I might declare, let's say, A, and then let's say object A. I might declare another one, let's say C, object C. These two are called the static type. Apparently, they're different. Once you declare the static type, it can never be changed. Never, ever. That's a good thing about Java, a language like Java. You cannot change it. The compiler will keep track for you. What about dynamic type? Dynamic type basically is about the type of objects the reference variable is storing the address of currently. That's the complete definition. But let's take a look. If I say this, if I say equals, whenever you have the new keyword in Java, you know that you're creating a new object. That one, you're creating a new dynamic type for the reference variable. And what can I put over here, right? Let's say the constructor simply take no parameter. What can I put over here? According to this hierarchy, and Farrads, let us know. Any descendant classes of A. Well, if you haven't really heard about descendant classes before, think about descendant classes are all the subclasses at every level, including the class itself. So here, A here is the static type. What can be the dynamic type? It can store the reference of. It can be A itself, or any classes that's lower in the hierarchy. All right? So here, the question mark here, any, the proper name will be descendant classes. Any descendant classes of the static type, which is A, including A itself. All right, let's say for now, I'm going to put maybe C, which is valid. All right? What's happening over here is we have some object A. Dynamically, it is pointing to some objects of type C. Do you guys remember how we can check the dynamic type in 2030? There was one operator you have to use. A single word. Type of? No, I don't think there's such an operator, but the idea is good. Something else, starting with I. Instance of, okay? At this point, if you say, you try to evaluate OA instance of, and then if you say C, it's going to be true. If you say OA instance of, for example, D is actually false because the dynamic type over here is C. All right, hopefully so far so good, right? Okay, question? Yes, it will be true. I can write it down. If I say OA instance of A, it will also be true. Basically, when you say instance of, you're basically checking what's the dynamic type at the moment. If the type over here is a subclass of its dynamic type, if it's the class itself or its superclass, you'll be okay. Right? That's kind of subject to some rule back in 2030. I wouldn't dive much into it. Okay? But you may want to review about instance auth, maybe back in 2030, right? I'm just reminding you quickly. All right, let's go a little bit further. Let's say I have another one here, OC, static type is C. So I can say new D. This is also fine because D over here is a subclass of the C over here, right? It's valid. And let's now bring something, okay, let me say one more thing. The fact that, let me briefly remind you what polymorphism is about. This part over here basically about the assignments, okay? When you say this assignment over here, any objects of type that's a descendant class of A is valid for you to do the assignment. This is something called polymorphism. Polymorphism simply means at the runtime, you might change this reference over here from this object to just another object of a different dynamic type. So you can keep changing. I'll try to give you a little bit more example, but that's polymorphism. Okay. And I think that's enough for this page. Let me just give you one more page. Okay. I want to just talk a little bit more about polymorphism and dynamic binding, and then we can move on to stack. Okay. Let's say we still got this hierarchy here. So let's say object A is new C. Let's say. And let's make some assumption. Let's say I declare some method void M. Okay, and the body of the method, let's ignore that. It's not important. All right. Let's say it happens that at some point here, I decide to override the method by redeclaring it and then try to put some new implementation. You can think about this as overridden implementation. Right? That's also something you learn from 2030, right? Just overriding. So now, how many versions of M do we have? One version here and one version over here. And apparently this version in here is going to be inherited to class D. And the version of N for this class is going to be inherited from A. Okay? Let's now talk about polymorphism and dynamic binding together, and then we'll be ready to go on to the stack case. Let's say I got another one here, C, and then object C, which will be new D. Okay? This one is also fine because D over here is a subclass of C over here. Now, if I say OA dot N, if you don't mind, let me introduce one more. Let's say there are 3 versions. Okay, this is another overridden version. So overall, we got 3 versions. Version number 1, okay, let me start with the initial one. Version number 1, version number 2, and also version number 3, right? We got 3 versions, okay? Let's say this. If I have OA.M, very quickly, OA.M, which version of the M is going to be invoked? Should it be the version of A, since OA was declared to be A, or something else? Version of C, because C is a dynamic type, right? Okay, it's something called dynamic binding. Guys, that's a review for you, all right? So think about, because this one here is going to invoke version of M in C, which is currently the dynamic type. And some diagram might help. So far, I got OA pointing to some objects dynamically is of type C, right? Let's now try to do the following. If I say OA is assigned to OC, all right? By the way, This is also valid, right? I'll just tell you why it is valid. But to really know why, you have to maybe review back in 2030. Well, if you're interested, also speak to me privately. I can talk to you through it. To determine whether or not this assignment here will be valid, you check to see the static type for OC, which is C. You check to see what's the static type for OA, which is A. Which is A, right? And C here is a subclass of A over here. As long as the right-hand side has a static type that's a subclass of the static type of the left-hand side, then it's valid. All right, it's a rule. And let's say this is valid, and let's execute this. What's going to happen is we're going to let OA point to something else. Oh, let me use a purple, right, just to be consistent. So this one here is now going to let OA point to another object over here. And then OC, where's OC? Oh, let me just draw OC very quickly. From the previous one, OC was pointing to a new object over here, that's D, right? Sorry, let me do it again. Okay. Should have planned a little bit better. Okay. After this line, we got this. OA is pointing to dynamic type C. After this line here, we got OC pointing to dynamic type D. All right, no problem. And if I say OA is assigned to OC, that means OA, rather than pointing to over here, is actually going to point to this particular object, right? It's what it is doing. Now, one last line. If I say OA dot M, which version is it going to invoke? It used to invoke the version in C, but what about now? Version D, right? Because dynamic type is now D. D does have an overridden version over here. So this is something you should really know how to trace, right? And we'll see some application like this later, okay? And this one here is going to invoke version in D, right? So we summarize very quickly about 1, 2, 3, and also 4, okay? So one final remark. The fact that OA over here, let me do, okay. You can see OA over here, the same variable OA, and also OA over here. The fact that we can change its dynamic type. These two assignments over here is called polymorphism. You can change the dynamic type at any time. You can change the shape. On the other hand, if you look at these two lines, if I call this one here, call this method here, and also try to call the same method over here, these two are called dynamic binding. Depending on what the dynamic type is, you're going to invoke the corresponding version. Dynamic binding. Dynamic binding. Right? So these two terms are very important. Polymorphism and also dynamic binding. All right? It's a little bit sketching around, but you can easily put this one into Eclipse and try out, right? It's a very quick recap from what you know already. Do you guys have any question about this, polymorphism and dynamic binding? You'll see this term in the slide as well, okay? Any part you want me to review again, or you're fine? All right. Let's now move on to the stack and see how this can be reinforced again. All right, so this is our stack, right? If you remember, we got some stack interface, like a superclass, and we got two subclasses, array stack and link stack, right? We got two possible implementation. In general, it can be as many as you like, okay? So these are the three. And this part here, just the implementation, I'm just including it over here. I'm going to focus more on polymorphism and dynamic binding, okay? I want you to take a look at this, okay? I want you to, first of all, look at polymorphism. You can see here I declare S to be of type stack of string. So this stack over here is the static type. And then the array stack over here is dynamic type number 1. Okay? And then if you look at some later line, S is reassigned to another dynamic type. This is dynamic type number 2. So you can think about this assignment over here and this assignment over here. These two illustrate polymorphism. Okay, I'll try to be a little bit careful. Polymorphism. Again, meaning that you can change the dynamic type whenever you need to. What about dynamic binding? I want you to look at, for example, S.push over here and S.push over here. Okay? If you look at these two lines, they are completely identical. However, are they calling the same piece of code in Java? Not really. Okay? Very quickly. You can think about after this one here, we say S is really pointing to some array stack. You can think about it simply pointing to some array stack. Array stack. And then part of its attribute called data is going to point to some array, right? That's what's happening up to now. And then when we try to say we want to reassign that to be a link stack, that means S is now going to point to another object over here of a different dynamic type. It is called link stack, where the data itself may just be pointing to some link structure. Right? Like that. Are you guys okay about this? Okay. So S.push over here is going to invoke the push implementation in array stack class. More specifically, it is the push over here. On the other hand, this S.push over here, because the dynamic type is now link stack, is going to invoke the push implementation in the link stack class. And of course, I'm not including the code over here, but you can think about what we discussed last time about the link stack, which is about either strategy number 1 or strategy number 2, right? Okay, just to mention. All right, and for the actual tracing for the push is rather simple, right? Just about the different operation that we spoke about last time. So for that one, you can just do by yourself. But what's really important, before I talk about the last bit about polymorphism and dynamic bindings, is you really want to know what static type is, what dynamic type is, and how they may change, and how to trace. All right? Let me say one more thing that will be also useful for you. The stack itself, as you can see, is generic. Okay? Let me just get it, and then I'll tell you what I want to say. It's a very useful programming concept, which I think you ought to know. Okay? I'll put it down, fresh. That'll be the last bit I want to talk about for this part. Okay, over here is something called polymorphic collection. In this case, polymorphic stack. Polymorphic collection. And in this case, we're just talking about a stack. Later on, when we also try to show you the implementation for queue, it will be similar. Okay? Let's see exactly how. And again, let me bring back the inheritance hierarchy. Let's say I got class A over here. I got class B over here. I got class C. Let's make it a little bit simpler. I got a method over here. I also got another overridden version here, right? That's a setup. How can the stack itself be polymorphic? That means when you actually want to push something onto the stack, that itself may be subject to some inheritance hierarchy. What do I mean? I'll show to you. Let's say if I have, let's say, stack, and then let me put A. All right? The A here is referring to the top of the hierarchy, right? That's valid. Let me say just stack. And over here, you can say new something. This is not so important for now. All right? It can be array stack, it can be link stack, whatever you like. Okay? And then, how can I push? As soon as I put A over here, it will be as if I replace every occurrence of E over here just by A. Okay? And now the question for you. If I want to say S dot push, what object type can I push over here? Since I said it's polymorphic, you want to immediately link to the following concept. If that's polymorphic, that means dynamic type can be multiple candidates for me to consider. Anybody? Ferrets? Yes, exactly. Because you can see that for the push method here, oh, I forgot to replace. This one here is also A. Okay? So this will be any descendant classes of A. All right? So I can put maybe new A here. I can also put new B here. And I can also put new C over here, because they are all descendant classes. Okay? Let me just illustrate one more thing. Okay, this one just for your reference. But let me put 2 lines. If I say S dot push new A. Okay? Anonymous object, right? You learned about it before. Also S dot push. And then new C over here. Okay, so these are the 2. What's happening over here conceptually? If this is a stack, I push some object A, okay? And then I push some object B dynamically. Oh, sorry, C. All right? And now, what I want is like this. If I say A on the top, so let's say objects, is assigned to S dot pop. And then I want to say objects dot M. Okay, line number 1, line number 2. Line number 3, I might say OBJ is assigned to S dot pop one more time. And number 4, OBJ dot M. All right? Now, for number 1 over here, we're going to pop the top of the stack. That's going to give us back an object of dynamic type C. Agree? So that one there is actually going to make sure objects at this point here has the dynamic type C. And then when we try to, so after that, it's gone. And when we try to invoke the method M, it's going to call the version in C. All right? And one more. If we try to do another reassignment here by saying s.pop, that means we're going to pop it up, and then obj at this point is going to store an object of type A. Now, if I say this object.m, it's going to call the version that's in A. Right? You can see polymorphism and dynamic binding even work at this level. Right? I'm assuming that you guys kind of have some familiarity with the polymorphism and dynamic binding from before, but this might be something new to you, but you ought to know. Right? Okay, any question about this? No question? Everybody's okay? All right. All right. That's about the first part for this lecture. I just want to make sure static type, dynamic type, polymorphism, dynamic binding, and finally, polymorphic collection. In this case, polymorphic stack. Make sure you review them and let me know if you got trouble. All right, before we take a break, why don't we do one example to talk about how useful a stack can be. Talk about one, take a break, and we'll do another two after the break. Okay? Let's take a look. So so that's about what we just went over. You can see dynamic binding here. Okay, polymorphism and dynamic binding, something I just mentioned. You can study the slides too. All right, the first application, which is very common. I'm pretty sure you try to solve how to reverse an array back in maybe 1021 or 1022 in the first year. You can easily just maybe by adjusting the loop counter to do it. But you can easily use a stack to reverse because it's last in, first out. Okay? Let's go over the first example here. It's rather simple, but I do want to show you another useful feature of Java. Okay? We'll talk about how you can declare generic parameter at a class level. Right? You can see the generic parameter E is declared right beside the class or the interface. That's one option. Okay? Guess what? You can also introduce generic parameter at the method level. That's also a very useful feature you may want to know. Okay, I'll show it to you. Now, I want you to take a look over here and focus on the header of the method and watch out where the generic parameter was given. So here we say public static and return type, name of the method, parameter, and there is an extra generic parameter over here. Okay? Interesting, huh? So, first of all, you want to identify this right away. This is a generic parameter declared at the method level. Generic parameter declared at the method level. Okay? So where do we use this E over here? The E here, and also the E over here. Right? And also the E over here, of course. So these are the three places where once E is known to us, they will be instantiated accordingly, like what we talked about before. E here, and E here. All right? Let's see how it works. Without actually diving into exactly how it works algorithmically, let's see how we can call this method. It's called reverse, right? You can take a look at, oh, that's reverse over here. Okay? I want you to look at two lines. One line here, and also one line over here. All right? Stack utilities is the class where this method is declared. All right? And we're calling the method reverse, the same method, with different arguments. One is the names, the other one is the numbers. How does Java tell how to instantiate the E over here? You will look at the element type of the array you're passing. How? If you look at the names over here, you can see names is a string array. If you look at the numbers over here, it's an integer array. So as soon as they see it's a string array, so it's going to instantiate this E by string accordingly. And when you get to this point over here for this method call, it's going to see that numbers is an integer array. So E here will be instantiated into integer instead. Right? So there are two scenarios over here. That's why generic parameter can also be used and instantiated at the method level. Okay, I'll write it down. You can think about the string over here is related to over here. And the integer over here is related to over here. Okay, that's really what you want to pay attention to. Guys, any question about this part here? Yes? Integer array versus just array? Int array. Oh, I think it's because for Java generics, I think I briefly mentioned last time. So for Java generics, they wouldn't allow the E over here, the parameter, to be instantiated into some primitive type. It wouldn't be allowed. So you have to use at least a wrapper class, like an integer or Boolean. Yeah, it's a workaround. No way around it. Okay. All right, guys, that's about the typing perspective for this method here. Learn the syntax. I think it's very useful. If you want to apply this to any part of your project, feel free. I think it's a very nice feature for generic method. So you don't really have to declare several reverse, one for string array and one for integer array, the other one for person array. Just put a generic parameter. One piece of code, one fragment, which can be instantiated to any type you like. That's the beauty about generics. Okay. Let's now talk about how it works algorithmically. Not too bad. We basically say, if I want to reverse, let's just talk about this one here. Okay, just this one, the first one. So what we have for the input, let's say names. Names is simply just an array of 3 elements. Okay, 1, 2, 3. We got Alan, Mark, and Tom. Alan, Mark, and Tom, right? That's the input. And what's going to happen if we try to reverse it? Of course, we should really expect to see another array, Tom, Mark, and Alan. But how does it happen, right? Let's use a stack. So the first line here, we're going to actually create a new buffer called a stack called buffer. So this is the buffer. And then we're going to go over the array of the input index by index from 0 all the way to the last index. And then keep pushing. So that means push Alan first. And then the next index, push Mark. And then push Tom. That's what we have done so far. Are you okay? Just push one by one. And then we're going to somehow reverse it by doing the following. This part over here. All right? So we're going to say, now still going over, so this part over here, we're still going over the array one by one, from left to right still. And then AI is going to be either 0, 1, or 2. Every time we want to reassign the array, we're going to pop something from the buffer. What's going to be the first one? Tom. And then we're going to reassign this to be Tom. The next one to pop will be Mark. That will be just Mark. And finally, pop this one here. This will be Alan. That's how you can reverse an array in place. So we don't really have to create an output array. We don't have to. Just reverse the input array. Okay, I will mention one more term. It's called in place. Reverse. Okay. All right, that's the first application here, very standard, just by using the LIFO, last in, first out property for the stack. All right? Is that okay for you? Okay. Questions before I take attendance and give you guys a break? A question?
So this is more of a general software question. So I know we're learning all this in Java, but this is still practically part of the program. I assume that most of these concepts will just transfer over.
Yes, yes. So very good. The question was, for many programming concepts, like what we talk about today, are they transferable to another programming language? There are two parts I talk about today. Let me be very precise. For the part about polymorphism, dynamic binding, static type, dynamic type. So these are definitely the more OO concept. So you find any object-oriented language, or any language that supports an OO feature. Python does, C# does, and some other language, if they support OO, you can definitely have the correspondence feature supported. About generic type, it's also a very useful programming concept. Generic type has nothing to do with inheritance. So even for some procedural language, like I don't really have any example on the top of my mind, but many non-OO language will also support generics. So the conclusion is yes, many concepts we talk about in this course, they are transferable to other languages. You're not wasting your time. All right? Yeah. Yeah, I'm just trying to emphasize, right? Everything you learn in this course, they're useful in other languages too. Yeah, just maybe different syntax, you're right. Yes, yes. Yeah, for example, some other programming language, rather than using angle brackets, they might say square brackets. And then the idea is really the same, right? All right, guys, ready for a break? And if you can just get your mobile device ready, let's take attendance, take a short break, and then we'll do two more advanced application for Stack. Okay, let's take a break first. Okay. Okay, the poll, let's start it. Okay, you can check in, please. Yeah, any issue about checking in? If so, please come forward. Sign up sheet is here. Everybody's good? All right, thank you. Let's take a 2 minutes break, and then we'll come back for more example on the stack. 2 minutes. Okay, today no technical issue. That's awesome. Good. Yeah. Sorry, say it again.
I think I saw briefly you had some announcements from the beginning of the slides for this class.
About asymptotic analysis?
Oh, I'm not sure. Because I came late. So on the first slide.
I think maybe it's about the stack operation. When you try to implement the stack in an array, so we can analyze what should be running time for each one of them. Yeah.
So something like March 20th.
March 20th. Oh yes, I got it. So March 20th is your written test number 2. Before that, you want to make sure you finish the makeup lecture. I think that's what I meant over there. All right. All right, guys. 1 more minute, and then we'll resume. Okay, just 1 moment, and then we'll get started. Okay. Alrighty, let's resume, please. All right, the second application we would like to have is something called matching delimiters. And it's a very standard way of using stack. Again, because they got a LIFO property, so we can definitely take advantage of that even further. So let's see what the problem is, and we'll run through some example on some code. Again, the code has been made available to you, so you should really take a look and see how you can play with it. What the problem is, let's say we got delimiters, opening parentheses, opening square brackets, and opening curly brackets. Right? So we got 3 types of delimiters. And also we got closing round parentheses, we got closing square brackets, we also got closing curly brackets, right? Apparently, this one here, for example, should match this closing one. If you got this one, immediately follow this one here, you know that they are not really matching, right? You should really match 1 to 1, okay? And what we really want to have is something like this. The input is going to be a string. For example, this could be a single string over here. And then we want to make sure for any opening delimiter, there should be a closing one. All right? This one here seems to be correct. Right? You can see, for example, this opening one has a closing one. And this one is a little bit more complicated, but it's not too bad. You're seeing 2 opening one, the first one here, and the first one here, 2 opening one. But you actually got 2 closing one right away. So they also close it. Right? So this is kind of the matching problem we are having. Let me give you one example where it's not correct. What's wrong with this? Tell me exactly where it's wrong, if you can tell me. Let's say you scan from left to right. Okay, why don't you say?
There is a closing delimiter that is not of the same type.
Okay. Yeah, yeah. For this one, let me copy that to my page, and I will talk about this one. Yeah, this one is important to understand why it is not matching. Give me a moment. All right, this is what we have. All right, imagine this, and then we'll see why a stack can help so much. Go from left to right. The first one you see over here is the opening one. No error. The next one is also an opening one. No error. The next one is still an opening one. No error. Now I see a closing one. The rule goes like this. This one should match the closest or the last opening delimiter. And and guys, I'm pretty sure once you see the keyword last in, first out, we can use a stack, right? Just as a look ahead. Now, are we matching this and this? Indeed. So this one is still fine. So you can think about these two are basically matched together. These two are fine. Let's put a check. And then when I get to, let's say this one here is a closing one, you should match the last one that's unmatched. This one has been matched already, so we don't look at that. But now, is this matching here? No. So this one here and this one here, they are unmatched. This is the kind of process you will have to keep doing until you find something that wouldn't match. Okay? There are two problems over here. Number one, conceptually, how do we use a stack to solve it? Number one. Number two, how do you write Java code to manipulate the stack to implement this functionality? I will talk more on the conceptual part about how you can use a stack. I also try to go over the code a little bit with you, but you ought to really study the code a bit yourself too. All right, we're going to do both. But maybe we focus more on the conceptual understanding. Okay, over here. So when you look at the source code on the lecture site, this will be some algorithm, some method you can take a look. Oh, by the way, if you look at that, it's going to be using a while loop, which would correspond to the length of this input string that we're given. That's only a single loop from left to right doing the scanning. So it's going to be a linear time algorithm corresponding to the length of the string. Let's talk about it first. Okay, let's make sure. All right, so as soon as you see this loop over here, oh, let me use a different color. Let's say this. Okay, good. As soon as you see this unnested loop, so the running time is going to be big O of n. And the n here is the length of the string. Before I dive into the detail of the code, why don't we consider these input string and get some feel? All right, why don't we do that first? Okay, so these are the string I want to go over. Okay, 1, 2, 3, and 4. Okay, one by one. Okay, for number one, okay, I'm basically going to go over from left to right. The first one will be opening curly brackets, and then opening square brackets, closing square bracket, which means it's matching this. Take it out. And then I go to closing curly brackets, which matches this one here, so I can take it out. So after the first the first 4 characters, I still got an empty stack over here. Follow so far? Basically, you want to make sure every time you got an opening delimiter, push onto the stack. If you got any closing delimiter, try to pop it off on the stack if valid. If not valid, you find a mistake. You can return false. All right? Let's go a little bit deeper. The next one will be this opening parenthesis. So I'm going to put it on top. The next one will be opening curly brackets. And then closing curly brackets. Oh, so I can pop it off because it's matching. The next one will be closing parenthesis, which also match this. Pop it off. And I'm now reaching the end of the input, and my stack remains to be empty. That is correct case. All right? Are we following? Are you guys follow? Okay. Not too bad, right? Let's take a look at the next one. The next one over here, okay, I'll just let you take a look first. Is this matching? Not really, right? Okay, let's see exactly. This one here first, and then I'll go like this. And then this one here, go like that. Okay, and then this one here, this one indeed is matching the top of the stack. Pop it off. And then the next one. This one here is not really matching the top, right? They are not really matching. So we find some error. All right? Hopefully that is visible to you. Let's try another one. How about this one here? Matching or not? Not really, right? Well, basically, we can do a little bit faster. After these four, this, matching, we got empty stack. And then when you get to this one over here, you actually got just one closing parenthesis. Agree? And then you're now reaching to the end of the input. But you still got something over here, right? So it's not good. Okay. End of string. You know what? For this one, let me be a little bit more precise. Okay. I was a little bit not so careful when I say it. Let me say it again. After these four beginning characters, we got this opening, matching, and matching. So we got empty stack. But now we actually got some closing delimiter. So we should really look at the top of the stack, which is empty. In that case, we cannot look at that. All right? So that's why it's an error. End of string. Okay, so I should really say. So for this one here, has no matching top. All right, a final one. What about this one here? It's again a different case that would fail. This and this and this. We got three delimiters. Let's do that. Round parenthesis, and then curly brackets, and then square brackets, right? These are the three. And then we match the square brackets, which is good. Pop it off. We match the curly brackets, also fine. And then we are reaching the end of the input. But the opening stack is not empty. So that's error. We have some opening delimiter that's unmatched. End of input, but the stack is not empty. Right? So these are the four cases. Right? 1, 2, 3, 4. And I'm pretty sure you already know how to use a stack to really manipulate it at the conceptual level. But let me give you a little bit guidance on how to read the code. Right? The code is not too bad. It's very faithful to what we are doing over here. And I try to be very careful about using the color. I'll tell you why. I'm going to highlight the code exactly how we can find the different correspondence of the cases. I'll let you trace it. Okay? But for now, I will try to tell you the critical bit. The code has been a little bit clever about how we can match the opening and the closing in the following way. We define opening and we define closing over here. Each one of them is an array of the same length. If you think about indices, this will be index 0, index 1, and index 2. You can see at index 0 of the opening, it matches index 0 of the closing. And also index 1 at opening also matches the index 1 of closing, and etc. Right? They match. So what you want to do later is, if I got, for example, this particular closing character, how do I know if the top of the stack is actually matching? How do I know? Basically, I want to make sure the index of the current input character will match the index of the top character in the stack. If the index actually match, that means they match. Right? That's really the critical insight. So I want you to pay attention to this line over here. That's exactly what you do. Let me just show to you. This line. Right? You can see the index of the top, which is opening, will match the closing index of. That means they match. Right? You want to make sure this one is what you have to pay attention to. And we just got different if conditionals over here, right? I'm just going to highlight very carefully about what you should really look at, right? Let me just look at my notes quickly. Okay, for the first case, which is valid, it's going to correspond to this line. Just this line. Exactly this one here. So this is when the closing matches the opening. So that means you can keep going. That's why you can pop off the stack, like what we did. That's case number one. Okay? What about case number two? Over here. Right? When you got something that's unmatched, that's the blue one. And you want to look at the else part over here. Okay? That's the blue one, the second case. This case is when the closing not matched properly. Right? That's the second case. Right? What about third case? When you actually got some closing delimiter, but the stack is already empty. For that one there, it's going to correspond to this one here. This one here. That's also error. Okay, so this is closing not match by empty stack. All right. The final case will be this one here. When we actually reach the end of the input, but we still have some unmatched opening delimiter. Right? So this one here is actually going to be, let me highlight the final line over here. Okay, you want to make sure. Okay, so you want to make sure finally when you return, the openings may be non-empty. In that way, it will correspond to this case. All right. Yeah, I think I can leave the tricks to you guys. I'm just telling you, each case that we talk about over here, they do have their correspondence in the code. Right? But now that you understand this, it will be your job to look at the code and convince yourself. Now, any question do you have about how to manipulate the stack at the conceptual level? That's definitely something I can help you today. All right? All right, guys, you okay? Question? Okay, maybe you need time to think about it. All right? That'll be the second example. And we can move on to the third one, the final one. Okay? The third one is something called postfix calculation of a stack. So this part here just some informal sketch about a solution. But if you already understood about how things work at a visual level, you're fine. All right, that's the Java code I kind of went over with you. And postfix notation. Have you guys heard about it before? What are the infix? You can calculate in postfix. If no, that's good. You're learning something new right now. All right. Let me write it down. Give you one example right away. Okay. Okay. Let me take a look. Okay. Good. So we talk about postfix notation. Okay. And what you're very familiar with is the infix notation. Let me give you two examples so you can make some connection, make some comparison. If I got something like 3 minus 4 times 5, and I got another one, let's say 3 minus 4 times 5. And the principle is, if you got parentheses, that means you got to force the order of evaluation. And the evaluation should be from left to right. All right, that's a principle. I'm pretty sure you're fine with these two, right? Let's take a look at the corresponding postfix notation. For the first one, you basically have to do this calculation first, right? For the most basic level, the idea would be, oh, by the way, so here, this is called operand. These two. And this is called operator. For the postfix notation, the principle is operands first before operator. That's the principle. But let's see how we can apply that. For this part here, 4 times 5. So I'm going to write 4, 5 times. And magically, if you do in postfix notation, there'll be no more need for parentheses. That somehow the order of evaluation is embedded in the postfix notation itself. I believe this might be how people actually used to the calculation, but maybe many years ago. But okay. Guys, are you at least okay with this? Okay? And now we are saying that for this minus operator here, we want to actually calculate these two operands. So these two operands must go first before the minus, right? According to the principle. We already got this operand over here, the right operand, which is already here. I just need another operand to go before that. So I'm going to say operand here and also operand over here. So I already got the right operand. I just need another one. And then this will go last. It needs, you need some practice, but that's okay. I just want to at least give you some comparison. All right, so that's the one. Why don't you give a try? According to what we have said over here, if you are okay, what will be the postfix notation for this? Apparently, it will be different because the order of evaluation is going to be different, right? Yeah, try to maybe sketch on your paper to see what the postfix notation might be. Again, the principle is operands first before the operator. Okay, maybe there's some people there raising their hand. I'll let them try. Anybody want to try? Anybody? Oh, go ahead, please. Tell me the answer directly. Just tell me the answer directly. 3, 4. Minus? Okay. Ferrets, you agree or you don't agree? Oh, so what will be your answer? Tell me your answer. 5, 3, 4. Minus and then? Okay. Very interesting. Okay. I think both are valid, but they're a little bit different. Okay. Let's take a look. It's good. Let's see how we can analyze these two. Let's start with this one here and then this one. Okay. I'll keep both handy. This one tells you, of course, you're going to calculate. Let me use a different color. You're going to calculate this one, of course. So this part over here corresponds to 3 minus 4. Left operand, right operand. And the whole thing is a left operand. And then the right operand is 5, and then you do times. Okay, so that's actually correct. But let's see if that's your answer, so we can learn from that. Okay, so that one there. So you can see here, I see 5 here, I see 3 here, I see 4 here. 3 operands so far. When I see minus, what should I do? I should only find the last 2 operands. Again, last in, first out. That's why stack could be useful. All right? So that means this part over here should be an operation, which is 3 minus 4. And then we got 5 over here, which should be the left operand. and then multiply. So they're basically, well, they will give you the answer the same, but they're different, right? Okay. So I'm glad you mentioned that. Not exactly right, but it's another valid one. Okay. Question? Oh, absolutely. So I think here, that's why I didn't really put division and other things. Well, I would say don't worry too much. You just have to know how to convert to the corresponding one. Sometimes the expression may not commute. I agree. Yeah. All right, guys, conceptual level, are you okay? At least it's not too bad, right? Something new for you to learn today. Yes, question?
So I guess I kind of mentioned earlier, because what I have 3, 4, 5 plus 5.
Let's, okay, again, no, let me write it down. Tell me again, please.
3, 4, 5 minus multiplication. Maybe I can do it.
Okay, I tell you what this will correspond to. Very good. Let's try. This is also valid, but not what we want. Let's see. This one here first, agree? 4 minus 5. And 3 will be the left operand. And then multiply.
Same operands. If you treat the point in which the operand and the operator is operand.
Yeah, so basically the idea would be you want to make sure, well, if you really use a stack, you want to make sure you keep pushing onto the stack when you see operand. As soon as you see some operator, you want to pop off the stack. But now, when you pop off the stack, are you going to pop off 4 first or 5 first? 5 first, right? So 5 will be the first pop off operand. That should be the right-hand side. And the second operand to be pop off will be the left-hand side. Right? That's something you want to watch out for. All right? That's the conceptual manipulation. Let's now try to, okay, you know what? I got different input over here. Why don't we try a few? This is the principle, right? But I'm just going to operate it. Let me use 2 to 3 example, okay? Why don't we try 2 examples? The other 2, you can do on your own. Let's say input number 1, okay? How do we do that? So basically, what we have is like this. Okay, initially empty, okay? So 3, 4, 5. 3, 4, and 5. All right, and then we see some operand over here. The idea would be you want to pop off from the stack 2 elements. So which will be 5 and 4. 5 first, which will be the right-hand side. And then 4 over here, which will be the left-hand side. And then you apply the multiply. You will get, of course, 20. And what do? Push back 20. That's the result. And then you're going to move on to the next character, which is minus. And similarly, for minus over here, we're going to, right, so pop off 20 first, which will be the right-hand side. And then 3 here, which will be the left-hand side. So you will get minus 17. Are we okay? The only step which I didn't mention on this page is after you have calculated the result, you have to push that back to the stack. Right? That's something I didn't mention, but it's not too bad. How about do one more? Okay, the other 2, exercise for you. Let's do something that's not valid. Let's say this one here. Okay, this is not valid. And I would say you can try to convince yourself somehow this postfix notation correspond to this one here, which is apparently not right. Right? You can see from the infix notation, it's somehow missing some left operand for the plus, somehow. Okay, let's see. Let's manipulate it very carefully. I'm going to draw the stack over here. Okay, 5, 2, 3. 5, 2, and 3. And I see the plus. And then I'm going to pop off 3, which would be the right-hand side, pop off 2, the left-hand side. That's going to give me 5. And then I push back 5. Right? And then I will see some multiplication. And then multiplication over here. And then I'm going to pop off 5. Pop off 5. That will give me 25. And I'll push back 25. I'm not done yet because I still have this plus over here, which is annoying. This plus tells me that, I'll put a plus here, I should really pop off the stack for 25. But now the stack is empty. Where is that? Missing. So that's an error. All right? Agree? So guys, if you try, this green one here is going to give you some result. You can give it a try. Make sure after you use the stack to calculate the result, you should really get whatever infix result it should be. If you try the red one over here on the stack, you're going to get something like this, which is also error. You're basically getting some operation here, but you got some extra operand, which is not right. All right, so these two cases will be left to you as exercise. Yeah, 2 questions. You go first. Oh, I see what you mean. Very good. Space, exactly. So for example, if I want to do double digits, I might just say 34, maybe 46, and then 56, multiply and minus, yes. Yeah, just by space. Or you can say, alternatively, you can say you simply got an array or linked list of objects. And each object can either be a string or an integer. That's also possible. I believe your assignment number 4 has to do with this, I believe. So you can do some practice on this. Okay. I'm pretty sure you're looking forward to it, right? Maybe yes, maybe not. All right. Guys, that's the last example about using stack. I think if you really try to master these 3, you got a very good grasp about how to manipulate stack. It's a very simple and also very useful one. All right, any question? All right, and I got about 9 minutes or so. I believe I can finish the queue because I think queue is rather straightforward. Okay, I don't need to waste too much of your time, but let's do that. Okay, the slides is already there, so let me just go directly through the iPad. Okay, for the queue, what do you have to know? It's basically something called first in, first out, rather than last in, first out. First in, and then first out. And what operation do you have? You can create a new queue, and you can do something called in queue. It's kind of analogous to push on the stack, similar but not exactly the same. And also, how can you remove an element from the queue? It's called dequeue, in queue versus dequeue. Let's see very quickly. And the obvious way to visualize a queue is like this. Okay, when we first create a new queue, its empty will be true. Size will be 0. If you try to do first, that means you're trying to inquire about the first elements in the queue. No, you cannot do that. Exception. All right, let's say we want to do in queue. So after putting 5 into it, it will not be empty anymore. And the size has become 1. And the first element should be 5. Let's do another in queue of 3. And then it's empty, remain false. Size should become 2, and the first remain to be 5. That's really different from stack, right? There's no notion about last in, first out. First in, first out. First come, first serve, if you like. And in queue, another one here, and it's empty, will be false. Size will be 3, and the first will remain to be 1. You can see this part here is really, really different from the stack. The front always remain there until you remove it. But whenever you want to remove things, you go from the end of the queue. It's like a very normal, oh, sorry, let me say it again. It's correspond to daily life. If you want to remove somebody from the queue, first come, first serve. Remove from the first. Okay, let's try. If I say I want to dequeue over here, I'm going to remove 5 over here. So now it's empty, false, size decremented to 2. The first is now 3. Okay, and then if you say dequeue again, you're going to dequeue this one here, and false. The size has been decremented to 1, and the first element is now 1. Okay, and then finally, if you want to dequeue once more, okay. After that, you get rid of it, and then it's empty, it's false, and then the size will be decremented to 0. If you try to inquire about the first again, you'll be in an error because it's empty, right? Yes, question. Absolutely. Thank you so much. Fantastic. Yes. And one thing to note, if you look at the top, sorry, at the first. By the way, for Q, we don't really say top, we say first. Okay? The first element here, you can see this one here. The earlier an element joins a queue, for example, 5 is the earliest one, right? The earlier it gets removed. Gets removed. Okay? Okay. Okay, I got about 4 minutes, right? I think I will leave just one exercise about the queue maybe for next Wednesday. I can finish that quickly and then we can do the trees. Okay? But for now, let me just take advantage of 4 minutes. The way we define the interface is just the same as before. Okay, just notice that we still got generic parameter here, but it's now Q. We got size, we got it's empty, we got first as opposed to top. We got in queue as opposed to push. We got DQ as opposed to pop, right? So for Q, you can have more than one implementation. And we can discuss array Q, maybe just for today. I can discuss link Q very quickly on Wednesday. And circular array is something I included as optional references for you, but I really encourage you to learn about it. Circular array is also some favorite hot topic, maybe for a programming interview. If you want to get ready for that, you can also study for that. I'll leave that to you. Right, let's just go for one more, 3 minutes. Let's look at how we can implement array queue. Okay, you can see implements the interface queue and an array, right? This part here is very similar to array stack. Okay, so here is the idea. If this is your array data, okay, so here the idea will be the beginning of the array is the top, is the front, is the first of the queue. Okay, I might put some first element over here, and then, excuse me, and then I put another element over here, and then put another element here. As far as in queue is concerned, I just keep adding, right? But now, if I want to dequeue, what's going to happen? I need to dequeue this one over here, but I'm leaving one null space over here. What should I do? What I should do is I should really shift everything over here to the left by one position. By one position. So this is the dequeue operation. And obviously, that one cannot be constant because you got to do the shift operation for dequeue. So that will be linear time. All right, so how can you see that? If you look at the dequeue method over here, so you can see this is the shift that you have to watch out for. This is going to cause your dequeue method to be big O of n. All the other methods over here, like a size, is empty, first, in queue, etc. They are simply all the others. They are just constant time. Okay, one more thing to say, right? So you should really go over the code. That's really similar to how array works, but it's now first in, first out. I already explained the catch about using an array as for implementing a queue. Now, how can we resolve this linear time complexity? To really resolve this, you have to use a different kind of array. It's called circular array. To resolve this circular array. Yeah, it's optional material, but for your knowledge, it's something called circular array. That's what you will need to do. If you use a circular array to really implement a queue, it's going to make it constant time. All right? All right, thank you so much. And I will finish off the rest, and I'll see you on Monday for the programming test. Take care.